Hello viewers, in today's class we are going to discuss yet another important and very conceptual problem from functional equations involving the derivatives, right? And here we have a very interesting problem, and here we'll make use of the famous L'Hopital's rule to get the solution of this problem, right? So let us start. So here we have the problem, that is if f prime of x is differentiable and f double prime of x is continuous at x is equal to 0, and the value of the second derivative of fx at x is equal to 0 is m, then we have to find the value of this limit in terms of m, right? So this is going to be a very nice problem, right? So here we have to find the value of this limit in terms of m, right? So let us call this limit as, say, L, right? So L is limit x tends to 0, and we have 2 times f of x minus 3 times f of 2x plus f of 4x divided by x square, right? So now here comes the role of L'Hopital's rule, right? So L'Hopital's rule says that if we have limit x tends to 0 and we have two functions, say h of x and g of x, then this limit is equal to limit x tends to 0, and we differentiate this function h of x, that is h prime of x, and we find the derivative of g of x, that is g prime of x. So this limit is equal to this limit, provided that h of 0 is equal to 0 and g of 0 is also equal to 0, right? So for applying the L'Hopital's rule, we must have the quotient that is 0 by 0 form, right? So we'll apply this rule to this limit. So now let us take this numerator as h of x, right? So let us take h of x as 2fx, then minus 3f of 2x, and then we have f of 4x, right? So if we take x is equal to 0 here, then h of 0 becomes 2 times f of 0 minus 3 times f of 0, because 2 times 0 is 0, 4 times 0 is 0, so we have here 0. So this is 2 plus 1, because here the coefficient is 1, so 2 plus 1, 3. So we have 3 f of 0 minus 3 f of 0 is equal to 0, right? And let us take the denominator as g of x. So this is x square, right? So g of 0 is 0 square, that is 0, right? So we can get the form that is 0 by 0. So we can apply the L'Hopital's rule, and in the next step, immediate next step, we'll differentiate the numerator and the denominators separately with respect to x. So now we have the second step, limit x tends to 0. The derivative of f of x is f prime of x. Then we have minus 3 f prime of 2x, and then by chain rule the derivative of 2x is 2, right? And here we have f prime of 4x, and then by chain rule we have the derivative of 4x as 4, and in the denominator we have the derivative of x square as 2x, right? So here it is important to note that the derivative of f of 2x, see here we have f of 2x, so the derivative is f prime of 2x, then we differentiate 2x with respect to x. So we get here the derivative of x is 1. So we are left with 2. So we have 2 f prime of 2x, right? And similar is the case with f of 4x. So when we differentiate f of 4x, then we get f prime of 4x. And then the derivative of 4x, the derivative of x is 1. We are left with 4. And this is 4 times f prime of 4x, right? Okay, so now we have this expression, limit x tends to 0. We have 2 times f prime of x minus, this is 2 3s are 6, so we have f prime of 2x, and here we have 4 times f prime of 4x divided by 2x, right? Now cancelling the factor 2 in the numerator and denominator, we get limit x tends to 0. So we have f prime of x minus 3 f prime of 2x, and then we have 2 f prime of 4x divided by x, right? Okay, so now we have this limit, right? Now let us once again apply the L'Hopital's rule to this limit, right? So what we have limit x tends to 0, and we'll differentiate the numerator and denominator separately with respect to x. So now the derivative of f prime of x is f double prime of x. Then we have minus 3. The derivative of f prime of 2x is f double prime 2x, and then the chain rule applies here. We have 2, then here we have 2, and the derivative of f prime of 4x, f double prime 4x, and here we have by chain rule the factor 4, right? And in the denominator, the derivative of this x is 1. So now we have limit x tends to 0. We have f double prime of x. Then we have 3 2s are 6. 6 f double prime of 2x. Then we have 4 2s are 8. And then we have f double prime of 4x, right? And here we have now got rid of this denominator, right? Okay, so now if we take the limit, that is x tends to 0, we have f double prime of 0. So substituting x is equal to 0 in this expression, we have minus 6 f double prime of 0, because when x is 0, 2 times 0 is 0. And here we have f double prime of 0, because when x is 0, then 4 times 0 is 0. So viewers, we have got this limit, right? And see, here we are given that f of double prime of f at x is equal to 0 is m, right? So we are given this value. So we'll substitute this value in this expression. We have m, then we have minus 6m, then we have here 8m, right? Because the value of the second derivative of f at x is equal to 0 is given as m. So we have m minus 6m is minus 5m, then this is 8m, and this is equal to 3m, right? So viewers, the value of this limit is equal to 3 times of m, right? Or we can also say that this is 3 times the value of the second derivative of fx at x is equal to 0, right? Hello viewers, in today's class we are going to discuss one important problem from functional equations, right? And here we have a problem in which the derivatives are also involved. So let us first read out the problem, and then we'll see how we can solve this problem involving functional equations. So here we are given two functions f of x and g of x. such that f of x is equal to e raised to 2x times g of x, right? And here we are given a functional equation, f of x plus y is equal to f of x plus f of y, right? And g of 0 is given as 0, g prime of 0 is given as 4, and here g and g prime, that is the derivative of g, are continuous at x is equal to 0, right? So we have to find the function f of x, or in other words we can say that we have to find the form of f of x. So let us start with the definition of derivative of a function, right? Now see, we know that the derivative of a function f of x is defined by this limit, that is limit h tends to 0, and we have f of x plus h minus f of x divided by h, right? So this is the definition of derivative of a function f of x. So now here we have the term f of x plus h, right? So f of x plus h, and here we have the functional equation f of x plus y is equal to f of x plus f of y. So if we replace y by h, then we can write f of x plus h as f of x plus f of h, right? So let us substitute the value of f of x plus h in this limit, right? So we have f prime of x is equal to limit h tends to 0. We have here f of x plus f of h minus f of x divided by h, right? Now see, these two terms get cancelled. So we are left with limit h tends to 0, and here we have f of h divided by h, right? So now the value of f of h can be obtained from this equation, right? So here we have f of x is equal to e raised to 2x times g of x, right? So f of h is limit h tends to 0, and f of h is obtained by replacing x by h. So we have e raised to 2h, here we have g of h divided by h, right? So now f prime of x is equal to limit h tends to 0 e raised to 2h and g of h divided by h, right? So now in order to calculate this limit, we'll take help of the L'Hopital's rule, right? Now see, here the numerator is e raised to 2h g of h, right? So the numerator is given as e raised to 2h g of h. So when we take h is equal to 0, in the numerator we have e raised to 2 times 0 g of 0, and g of 0 is given as 0. So the numerator is 0, right? And the denominator is h. So when we take h is equal to 0, so the denominator also becomes equal to 0, right? So here we see that in the L'Hopital's rule, we are getting the 0 by 0 form, right? So what we will do, we'll differentiate the numerator and denominator with respect to h and separately, right? So we'll separately find out the derivatives. So we have limit h tends to 0. Here we have f of x, and to find out the derivative of numerator, we'll apply the product rule. So here we have e raised to 2h, then we have g prime of h, then we have g of h, and then we have the derivative of e raised to 2h as here we have e raised to 2h, then the derivative of 2h is 2, and in the denominator we have the derivative of h as 1. So now we have f prime of x as e raised to, here we have the limit notation. So limit h tends to 0, we have e raised to 2h, and we can take e raised to 2h common. So we have g prime of h plus 2 times g of h, right? So now let us take the limit here. So f prime of x is equal to, taking h is equal to 0. Here we have e raised to 0. Then we have g prime of 0. Then we have 2 times g of 0, right? So f prime of x is equal to, e raised to 0 is 1, g prime of 0 is given as 4, right? So here we have 4, and 2 times g of 0 is 0, right? So now we have f prime of x is equal to, this is 0, so we have simply 4, right? So we have obtained d by dx of f of x is equal to 4, right? So now here we have a differential equation. So now integrating both sides, so we have d by dx of f of x, here we have dx, and here we have 4 dx, and c is the constant of integration, right? So here the integral of the derivative of f of x is the function itself. So we have f of x, and here we have 4x plus c, right? So f of x is a linear function in x. So now let us find out this constant, right? So in order to find out this constant, we'll make use of the boundary conditions. So here we are given that when x is equal to 0, we have f of 0 is equal to 4 times 0, and this is the plus c, right? So c is equal to f of 0, right? So our constant of integration is equal to f of 0, and f of 0 can be obtained by taking x is equal to 0 in this equation, right? So see, for x is equal to 0, here we have f of 0, and we have e raised to 0, because taking x is equal to 0, 2 times 0 is 0, and here we have g of 0, right? E raised to 0 is 1, g of 0 is 0, so here we have 1 times 0 is 0. So f of 0 is equal to 0. So the value of c is equal to 0. Taking c is equal to 0 in this equation, we have f of x is equal to 4x plus 0. So f of x is equal to 4x, right? So this is the form of the function f of x. So viewers, here we have seen that the form of the function f of x is a linear function, right? So f of x is 4x. Now let us find out the form of the function g of x. So taking f of x in this equation, we have 4x, and we have e raised to 2x times g of x. So g of x is equal to 4x divided by e raised to 2x, and this can be written as 4x e raised to minus 2x, right? So the function g of x has the form 4x times e raised to minus 2x, right? So viewers, this is a very interesting problem, and we have seen that how we can find out the solution of this problem by making use of the definition of derivative of a function and other concepts.